Hello everyone, welcome back to day 2 of my cloud computing series. And today's what we are going to learn is how operating system puts up. Second, difference between 32-bit and 64-bit. And third is different types of storage in computer. And fourth, how operating system creates process. Fifth, what are the different process states, like process states in operating system. So we are going to learn this. So I'm going to directly on my notes where I can explain you. So what is boot process? Boot process is nothing but turn on the computer process is called boot process. Like you are turning on your laptop or computer is called boot process. So there are 5 steps in boot process which are happening. So we are going to learn this. First is you have to just power on. So it's going to supply every device powers, like supplying power to every device like motherboard, hard disk, everywhere in your computer or laptop, anything. And second, CPU load, BIOS or UEFI. So what is BIOS? BIOS nothing but basic input and output system, which is basically used in older generation laptops and computers. Right now, this UEFI is using Unified Extensible Framework for Interface. So CPU basically loads BIOS or UEFI. So it's like a chip. It's a ROM. It's like a chip where CPU utilization in this second process, like second CPU utilization is happening, and after that its loads goes to BIOS chip. CPU goes to BIOS chips, and in BIOS chips, third process in BIOS chips or UNIFI run the tests and initials hardware like RAM is there, or like RAM is there, disk is there, anything like like anything is there, like it's checking uh, testing hardware is there or not, like in your laptop or not. Is not there, then it will show you a error in your screen. If it is all like all devices there, like disk, RAM, anything is there present in your laptop or computer, then it will test run the test like it's there or not. If shows all is good, then your CPU is going to load. Second thing, load some settings from a memory area backed by Qamo battery, and after that program loads with settings, like a program like in BIOS there is a program which loads settings which running on like post like which power on self test, like RAM testing on itself or some program. So it's basically testing like is something is there or not, like that. Then it will show yeah it's all good. Then we will jump to the like BIOS, go to hands off to the boot device. What is boot devices is where boot device is present. Boot device is present in HDD or SSD or CD or USB device. So boot device basically nothing like is there is a bootloader in boot device. There is a bootloader, like there is a program which actually on operating system. So what is happening, BIOS, like if this program test cases is all happening and all devices are present like RAM and all, then what BIOS going to do, go to boot device, and boot device what it's going to do, bootloader load the program who on the actual operating system. So in like 90s or 2010 or there is like using their master boot record, and this is used by BIOS. Right now UEFI used EFI extensible framework interface. Okay, so this used by UEFI, and it's present in like mbr master bootloader is present in the zeroth index of a disk. Like in a disk, zeroth index is present. And but EFI present in a disk, but there is a partition, separate partition of a bootloader or a, like this one in a disk. So it's fast, mm, uh, and better than BIOS. That's why right now this is using in most of the laptops and laptops and computers. So after bootloader loads the program, bootloader loads the full OS, like boot loads all the like that program, like on the actual um, like initialization of operating system. S- then your like your laptop will open like that. So whenever you just on that your press your laptop button, so you can imagine this all these things happening within a fraction or within a second. They all check everything is happening or not, like these five steps is happening, then your computer laptop or computer is opening. So it is an interesting part. If you learn this, you will like, okay, this happen, you got to know. This is like you are a computer student, so you have to like know this, how boot process is like that. So this is basically boot process. Now we are going to learn uh, 32 bit and 64 bit in operating system. So in short, I will say that 32 bit is used in like in past, or like in older version computer and laptops. Right now 64 bits using recent laptops and 64 bit is better than 32 bits, because if you see what is this 32 bit and 64 bits, somewhat like it's a register. Okay, if you see, like if you in 32 bits, they're only for like only 32 bits are present only, and in that there is 8 bytes in 4 bytes in each, in for like 4 bytes data hold कर सकता है. It's only storing 4 byte holds data. It's hold like 32 bit only store 30 like 4 bytes data hold कर सकता है, and 1 bytes is equals to like 0 0 0 0 0 like 8 like that. रजिस्टर जो पे एक्चुअली कंप्यूट होता है, लाइक रजिस्टर द एक्चुअली वेयर द योर multiplication everything is happening in register. So register is nothing but like is a cpu, like is a main thing where your actual process computation everything is happening in register, so it is important. So this is CPU1 and this is CPU2. So in 64 they hold too much uh, they hold large amount of data, because it 8 bytes, and it store like 64 bytes, and it is only 30, and it store 4 bytes like that. एंड इफ़ यू सी सीपीयू का काम होता है मेमोरी एड्रेस पे जाके डेटा फेच करता है. Like if you see, CPU will go to the RAM and see these like this and take them from that data fetch, like it is fetching that data from this RAM. It's like basically it's saying like that. So if you say 32 bits, so 2 to the power of 32, this unique address will be stored in 32 bit. So it only supports 4 GB data, so it's less nowadays. If you see, this 4 GB is not enough for today's world. So then 64 byte so register introduced, where if you see if you like 2 to the power of 64, then this amount of you can store data in this 64 bytes. So this is large amount of data you can store in this chip. So that's why nowadays 64 bits is storing. So first point you get that 64 is why 64 bit is good and like good and better than 32, because it's whole large amount of data better than 32. That's why. And if you see, if there is 32 bit, and if your computation is happening in 64 bits, so what will happen in 32 bit? It first will calculate this 32 bits and save in this, and in then calculate this 32 bits, then store in this, and then add this. So there is a two cycle. If you see, when you're if you uh, time, like you see, what is cycle? Cycle is nothing but like it's in operating system or in CPU utilization is most important, that how much CPU cycle is doing. So less CPU cycle is doing, the program is that much good. So that way, if 32 is not good, because it have doing this 64 byte of multiplication or computation is doing two cycles. But what 64 will byte do, whole that 64 byte at one cycle it will compute that thing. So it running in one cycle. That's why 60, this second point you will get, if there is a computation or any calculation is happening, or a data storing and happening, then this 64 byte is better and better than 32 bits. You got this second. And advantage addressable space, different locates and line, like different, I have said it, different you can locates them. Now you can understand that resource uses, like you can only 64 byte 4 GB, like that only. So performance wise also, 64 is good, because if you see, if you there is like calculation or multiplication anything happening, so 32 bits takes two cycle, but 64 byte take only one cycle. That's why in performance also it good. If you see, once instruction cycle 32 bits take one data process, one instruction cycle, 64 data dates fetch. Okay. Compatibility. See, if you see, 64 byte CPU can run both. If you see, 64 byte can also run on 32 bits also, like 64 byte CPU can run both 32 byte and 64 byte in OS, while 32 byte CPU can only run on 32 byte only. If you understand, 64 can run with 32 also, but 32 cannot run with the 64. Basically it's saying like that. And in better graphic performance, if you like nowadays playing PUBG and all, or higher graphic games, then 64 byte is always preference, because it's far best better performance in graphics also. This 64 is reliable, because it's because of the computation, because of the data, because of the performance, everything. This 64, so nowadays 64 byte CPUs using. Now I think you understand. Now we will go to the second point of us, types of storage. If we search type of storage in computers, there is we can divide into two majors: primary memory and secondary memory. In secondary memory, electronic device, magnetic device, optical device, and magnetic device, this all disk are present. Sorry, I said device, it's disk are present in secondary, and is cheap. And that's why it's we can buy in 1000, you can buy 1 TB or 500 GB, because of this chip. But in like in primary memory, there is a main memory, cache, register. So if you see, register is so close to CPU. That's why CPU can fastly access this register, and they in this in only the computation and everything calculation is happening, any your process happening in this year only. So that's why it's uh, kept here, close to CPU. so CPU can fastly access this register. And that's why, and it is like you don't have to like no no error and all. So that's why you always use uh, like precious or like most hardware like thin material, so material in you are using in this. So it's basically it's very high in price because of you are using so much precious or demanded material. That's why. After that there is a cache. If you see UCP there in a program, there is a multiple cycles of there is a multiple of output input, then it will be stored that, so that CPU can't go there like to main memory. It will directly access this that repeating input or output anything in a program or in a process, that will be safe in this for temporary basis. After that there is a main memory. So in main memory your program is all there, and this you can it's in if you see main memory RAM or you this they why they are so high, and there are only like 16 GB 8 RAM. That's why they are like so small in size, because you are using most demanded or most precious material of world. So that's why it's higher in price, and it's most important and so. And if you see you can buy in 1000 and 2005 1 TB or 2 TB also, but you can't buy 1 TB in RAM because it's so higher in rate. Now we will understand what, like I have explained you, that's why what is register, what is cache, and what is memory, and this disk. So now what the benefits? If you see cost best material, if you see in this, you use best material of earth minerals in this to make the register or cache or main memory. That's why it's so high in cost. So you can buy 8 GB or 16 GB RAM. You can only see that type of main memory. But if you see a hard as in secondary memory, it's not using that much of best material, so that's why it's cheap. That's why you can buy 2000 in 2000 rupees, you can buy 1 TB or like 500 GB like that, because you are not using best material. That's why. In access speed, you can see I have also told you like a register is so fast, like CPU can fastly access register, after that cache, after that main memory, after that this second memory can access. Like if you compare this, so this is fast, after that this cache, after that main memory, after that electric. So if you see like you can also see that it is because of close to this, and using hard best material, that's why also. And based on that like uh, importance and all, that's why also. So CPU is close to this, close to this, close to this, that's why so fastest access. If you compare like who is CPU, how CPU can which is the fastest in between, CPU can access in primary memory and secondary. So obviously you're going to say that primary memory can, like CPU can fastly access this primary memory and take time to access secondary memory. So now you understand the accessibility. And storage size, I have to explain why it's uh, because we are using best material, that's why also it's uh, higher in cost. If you talk, I'm talking about primary memory, like main memory, cache, register and all. So it's small in size, but that's why it's higher in cost. Like it's because you are using best material in that to make that RAM and all. but you are not using that bus materials in disk and all. That's why it's like cheap. So if you say comparing, then primary memory, like secondary memory, has large amount of storing storage, uh, storage, and primary memory has not large amount of storage. And volatility means like how much, uh, I have explained you like this accessibility and all, and reliable and all. Like if you add, like you can add like that only. And now I'm going to explain you how operating creates a process. Operating system creates a process. Okay. So firstly, process, like if you .cpp, it's a extension. And uh, if you go to the compiler, what compiler do, compile that and create a executable of that file, and then it's become program. What is happening then? For example, TikTok OS प्रोग्राम को कन्वर्ट करता है, और टिकटॉक जो है उसको कन्वर्ट करके प्रोग्राम में कन्वर्ट करता है, फिर उसको प्रोसेस में कन्वर्ट करता है, लाइक या सो करेगा. एंड इफ यू सी करेगा ओएस प्रोग्राम को प्रोसेस लाइक दैट. So why process? If you do any, if you want to do any task, anything in your you want to perform, so you have to create a process. That's why process is important. Like इस यूज़र को कोई काम कराना है, तो यूज़र को वर्क या वे कराना है, तो प्रोग्राम को प्रोसेस में कन्वर्ट करना ही पड़ेगा. How operating system creates a process? Here are the 5 steps. Okay. First, load the program and static data to memory, into like in take out into disk into RAM. So that loading into RAM, that is they are saying, load the program and static data to RAM, loading that data. Okay. After that, like I have giving, I have the diagram also. You're taking your program into from disk 2 and loading that data, that program into RAM. That is the first step. And allocate runtime stack. What is meant? Stack is a part of memory used for local variables, function and argument, return value. Like this thing is written in your program and all. And allocate heap. What is heap? Part of memory used for dynamic allocation while you are running while you are running your program and all. There you can ask from users and all. So this dynamic data is you store in heap, basically is saying that. So first and second, third, this step will happen. After that, fourth, IO task. If it like input and output handled by this, in output like input handled by this, output handled by this, and error handled by this, it going to giving that task by this. And after that, OS what you hand off control to main, like you why you are like all this happening, like after doing this 4 step, what operating system will do? Operating system will hand off all control to your main program. After that, whatever you have written, that will be done that by CPU. And then if you have written your value, then your operating system got to know, okay, the program is has done, like that. If you're not returning any zero and you're in any condition, then then your operating system don't know where, how, like program is done or not, or error or not. So you have to always return the value in your program. It's good. Process to memory. Now we'll understand the architecture of process. So this is the architecture of process. So where this is the test compile code. Okay, where you have written your code and all. This is the data, global and static data, and this is the heap. I have said you, this is the heap, which basically saving your storing your dynamic data, which like while you are running the program and you asking some input from user and all, that will be stored in this. And in stack you will know the variables and that will be stored in this. So this is the architecture of this. And when you, so if you have like have see this error also when you're running your code also, so now you can understand what is, now you can actually understand what is this error. So stack overflow flow means when you are not there is a program of recursive, and it's like repeating that program and variable storing, and that same storing and storing at that time, like stack, then stack, this will be take like a stack, and stack, in the stack your variables data and static data will be stored in that, like stack, that stack. Then OS, like operating system, got to know something is happening wrong, then what will be showing, okay, then it will be show this stack overflow flow. And if you see heap, then there is a dynamic data and storing in this. If you see that, it will be like if you not delocate your in your program like object and all, so what will be happening, it will be also like heap, or like this take heap, heap, heap. After that, sometimes operating system got to know, okay, that it is your RAM going to out of storage, then it will be show out of memory, like that. Yeah, and in stack of overflow also it will be show like out of memory. So that's why operating system give you these two types of error. So you have to for prevent that, you have to use base use set karo, like that. And you have to like delocate your object from unnecessary object from your in your code, like that. And attributes of process, if you can understand, like if there is a p1, p2, p3, p4, then there is a process table like 1 2 3 4, p1, p2, p3. There is a p1, in that p1 there will be a pcb, process control book. There all your process information is stored in this process control block. Process control, like pcb is so important. That's why, because through operating system, like if operating system want to like if operating system wants to differentiate p1 and p2, how it will be going to differentiate through this pcb only. So now we will understand what is pcb. So in pcb, this is the structure, like this is will be storing like this only. So process id, like unique identifier, like this, like unique identifier will be stored in there, like p1 has this unique id, like that. And after that, program counter, what is program counter, like on which position, on which line are you in, like if you are like in this program, you have like 1 2 3, and there is a io is happening, so you have gone. But after then you have come, so it will be stored like where you have there, or you, it will be like at which position you are doing, like fetching the instruction from the address in pc. So it will be pcc plus plus, then execute the instruction, execute the instruction, then you have going to this loop. So it's like, and with which line are you present in. And after you are plusing, then you are going to next to that. So basically, which line are you presenting in program, it's showing in this program counter. After that, process state, which new wait run, which state in these processes are there, this will be stored in process state. Priority, like on priority based, it will be stored in this one. And register, like save the register psu, like save the register psu, like means if I have said you, like if line 1, line 2, line 3 is happening, and line 4, at this line 4 something is io is have to do, so this process is gone for io. So before going, it stored that this happening, this have done, and after that this will have to do. So it will be stored in this. So after then this process will come, it start from fifth only. That's why its register is important, because it saved that only. Open file system, like you can if a process have to open files and all, this will be stored in this. and open devices, like open all the, like which device is open and all. It will be like doing that during that process, what file has open and all will be stored in this, and what devices and all have open and through during that process running, it will be stored in this. So basically PCB is so important, through which operating system will differentiate or any do content switching, anything will be happening through because of PCB, because PCB is like a information of a process, like it's storing information, whole information of a process. So now you can understand what is now we are going to learn process state, like life cycle or generation to termination, like starting from to termination, like that. So first is new. New is uh, like new is like I can give you, like from you're taking your program from this to new from that will be called a new, like program to process, like being done like that. Like if you see from this to new queue, then it will be like a new state. After that, ready queue means like there is a ready queue, and if that you are take your program to new directly, unlike new to ready queue, then it will be a ready queue, like that. And if you see running state, it's like a p1 allocated to cpu allocated to p1, like that, and it running that process on pc, that will be a running state. Waiting state, what is waiting state is like a waiting for completing io anything, then that will be a waiting state. If that I have explained you, if this 1 2 3 line have run, after that that program line fifth line has to do some io, then it will do some io and waiting in that one. Then there is in ready queue there is a space left, then it will go back to ready queue, like that. Now I will under going to and terminate state. If your running have done and all the process have done their work, then it will be terminated state, that will be process is finished, like that. So what I am going to do, explain you through this diagram. What you're taking your program from this to new, that will be a new state. After that you are doing like this to ready queue, then it will ready this, there will be a ready queue, and your process in ready queue, that will be called a ready state, like ready state, that process. So what will happen now, and ready queue is there, and that scheduled dispatcher has dispatch your process one in running state, like allotted your CPU. Then have that process has something has like running their process and all, and there is an input output, then it will be go there and waiting that input output and waiting there. After that it will go back to the radio queue, like that. Or if you say like that is running something. And time sharing, I have said you that there is a time sharing. If you know, we have yesterday learned time sharing. So what will time sharing, this process p1 has some 10 millisecond, like 1000 millisecond time sharing. After 1000 millisecond have done, then it will, there will be a software interrupt, then that p1 will go back to in ready queue or ready state. That is basically means, if your process have done all the work and all, then it will be in execute terminate state. So if you see from running to from disk to ready queue, ready state also I can say ready state, then that will be a job scheduler or long term scheduler. Or if you like ready to running state, that will be a cpu scheduler or short term scheduler, like that. Why I'm saying long term scheduler, it will like if you see it take from from your process or program from disk to ready queue or job queue. so it will like a it will like in a ready state. So what will happen, it's like a long term, and it will like checking every 1 minute. But in ready queue, from what CPU scheduler or STS, what it STS I can giving short form, what it will check in second, because CPU don't be idle, that's why it's checking that this process had just terminated, and it will be seeing okay it's terminated, fast go and dispatch that, and running that P2 will be allocated to that CPU like that. So it's important, that so much important. So I think you will understand STS like a short-term scheduler, and LTS like a long-term scheduler. And it will it's STS like CPU scheduler, and it is like a job scheduler, like in doing a job like scheduler. So what happening right now? If you see uh, job queue or secondary memory, like if P1, P2, P3, P4, so there is no like LTS always take care of no, not happening starvation. They will what LTS do, one IO process, one CPU process, one anything process like that, not same process like IO. In that what will happen, it will be going to starvation like that state. So that's why LTS has this responsibility to mix the process. So CPU could not be idle or could not be in a infinite doing that process. So LTS has that responsibility. And what STS has the job only taking fast check is there, that process has terminated, then check that and allocate that process to CPU. STS has this only. And in that only there is a MTS, mid-term scheduler swapping. If you see like degree of multi-program increase, LTS like that. Okay. Now I am going to explain MTS, mid-term scheduler. What is mid-term scheduler is, like this is your ready state, P1, P2, P3, P4, and P4 doing some allocated in a running state, and it's doing something process, and doing something, and something process and all. But then P1 has come to in ready queue or ready state. Then what will happen, P1 is too large, like it's taking two storage. So what will happen, this taking like it's 4 GB, and it's taking 4 GB and all that process. I'm just giving you an example. So it like for the 3.5 GB like that process. So it taking too much or too storage. So what MTS will do, it will do like swap out P1, P4 and P3. Why? Because is P4 has allotted and doing some work, but it's like swap out that dislocate deallocate that CPU and swap out into swap phase. And P3, like if P3 also taking some space, and if like P4 only having uh, swap out this P3 and P4. So what will happen, now there is a space. Now P1 and P2 can run. So then P2 have done some process and terminated. Then what will happen, P2 will be allocated to PCO. Then it will be like doing some process and all. In that, when P1 has allocated CPU, what will happen, then ready queue has space. Now what will MTS do, it will swap in means like again it will store P3 and P4 in ready state or ready queue. So in that through you can like store your storage like ready queue and all. So this is like a swap phase is very important, and it is a second memory if you see. So I think and now I can give you example like this process I will give you. If you like you are using your mobile, and you have opened so many application, TikTok, Instagram, Snapchat, and YouTube, and one more application. So what will happening now if you go back to TikTok, like if you like uh, go back to TikTok, if you like click that, and like I will like give you example. If I will do like this, close all like this. If I want to, I have so many like this, I have so many tabs. If I want to, like this is 10 tabs in my phone, and I have opened this 10 times. And TikTok I have like opened 10 minute before, and it's like that. And when I'm going to going back and click TikTok, TikTok will take time. Why? Because it store in a swap base. That's why it's taking time to load. It it's like that. You can now understand what is midterm scheduler is doing. I think I have explained you very well, and my like I have learned from every day I'm learning. So now like I'm going to like I have learned like from my first video that my video is too long. So what I'm doing right now is creating short videos, so saving my time also and saving your times also. That's why I'm creating short videos. So I think I hope explain you very well. Now we will meet day 3. Thank you everyone. Have a nice day.